So guys, I want to show an example problem on how to type in a certain problem for using Coulomb's law, right? So using exponents on this piece here, this free calculator, if you type it into your Google. So I'm just gonna show this question over here. Oh, there we go. Zooming out just a tiny bit. Yep. Okay, so the question has the fact we have an electric charge of 1.6, I'm sorry, negative 1.6 to the negative 19th coulombs. All right, the charge of an electron. And a proton has a charge of a positive 1.6 times 10 to the 19th coulombs in a hydrogen atom. Now, the distance between them is 5.3 times 10 to the negative 11th meters. So our equation, all right, is F is equal to K times Q1 times Q2 over D squared, or it may show up as R squared depending upon, all right, your formula. But it's the same process. So K, the value for that doesn't change. We were given that, and that is 9 times 10 to the 9th. We have our two values here is this negative 1.6 times 10 to the negative 19th and a positive 1.6 times 10 to the negative 19th. And all of that is going to be divided by D squared, which is this 5.33 times 10 to the negative 11th guy squared. So we're going to type this in to our free calculator. Do the top line first. So I'm going to do 9 times 10 to the 9th. Nope, that didn't work. Why? Because I did that a little too fast. So can I backspace? Yes, I can. I have to click this button, the X to the Y. And then you should see a little box show up. Now you can type in your exponent. Okay, cool. So I have that. I'm going to throw parentheses up, and now I'm going to do this negative 1.6, all right, times 10 to the, what is my exponent here? Negative 19th. Close your parenthesis. The next value is 1.6 times 10 to the negative 19th. Close my parentheses. So that is what my top line is going to be. So I do that and I get this whole big old number guy. All right. So what we got to do then is we got to divide this. Oh, no. Nope. See, now I lost it, but I can still go answer. Get rid of 0. Why is it saying 0? There we go. Okay, so the answer for my previous calculation, that negative 2.304 times 10 to the negative 28th. So now I'm going to divide that by, I'm going to hit parenthesis, let's see, 5.3 times 10 to the negative 11th squared. No, I don't want to do that. Get rid of that one. Squared equals. All right. So that should be our answer. Let me just double check on my calculator. If you're using one of these calculators, 9 times 10 to the 9th times negative 1.6 to the negative 19th times 1.6 to the negative 19th. Top line worked. Divide this by 5.3 to the negative 11th square it. Oh, that should have been 5.3, not 2.3. So it seems something is off. Well, let's determine this. So if I go back to the 9 times 10 to the 9th times negative 1.6 times 10 to the negative 19 times 1.6 times 10 to the negative 19th. Close it equals. Okay, so we get this. Now we want to divide it by, let's do this, double parenthesis. First parenthesis will be your distance is 5.3 times 10 to the negative 11th value that we were given. So negative 11. Then you're going to close that parenthesis and you square that and then close it. So now you have your double parenthesis action. And there. Okay, so that should be your final answer. And then you would basically type it out or show it like negative 8.2. We don't have to have all those decimals, so we'll just 2 decimals, negative 8.20 times 10. All right, that's what that little small e right there is representing, the times 10 to the negative 8th. And what is the unit for force? Newtons. So if your distance, all right, if the distance between your two charges has an exponent, when you type it into your calculator, do a double parenthesis. So when you do that, right, double parenthesis it. So parenthesis, parenthesis, your distance with its exponent, close the first parenthesis, and then square it, close the second one. All right, and then you should get the right answer. But if it doesn't have, right, this distance here doesn't have an exponent, you don't need to worry about that. You can just do 0.03 squared. Okay. So with that being said, I just want to roll through a couple things here. Today we're going to do an online virtual lab. All right, that deals with Coulomb's law. And what you're going to do is look at a couple different factors, right? So some of them, what you're going to be asked is, what makes a force attractive or repulsive? By experimenting with these things, right? By dragging the charges farther away or closer towards each other, does that change the fact that they are attractive or repulsive? What would you say that this force is, attractive or repulsive right now? Attractive, why? Yeah, because the arrows look like they're going together. It's good. So by changing the distance, that doesn't do anything. Okay, what if I change, what else can I change? I can change charges. What about this? Now that the charge on one of them is positive, right? Well, actually, no, the charge on both of them is positive. Now what do I get? Is that an attractive or repulsive force? Repulsive. Okay, well, what if they're, so both positive is repulsive, a negative and a positive is attractive. What if I made them both negative? It's also repulsive. So what determines whether it's attractive or repulsive? Like charges are going to repel, and opposite charges are going to attract. All right. So how is this comparable to Newton's third law? How is this comparable to Newton's third law? So what is Newton's third law? If you guys remember, it is for every action force, there's an equal and opposite reaction force. So like, our very simplistic version was if A acts on B, B acts on A, equal force in opposite direction. Now, in this case, it may not necessarily be the opposite direction, but what is going on here at these forces? If I change it from negative or positive 4 to a negative 5, what do you notice about the force on this charge by this guy, or the force on Q1 by Q2? What are these two values? They're equal. All right, well, what if I change this one also to negative 5 or negative 6? Are they still equal? Yeah. So Newton's third law applies to electrostatic force because both charges are going to exert an equal force on each other. All right, they're going to both exert an equal force on each other. Now, the magnitude of that force can vary with a couple things. The charge, the magnitude of the charge, right? So like the higher the number, you can see that the larger the force gets. So let's say I put this right here at this charge one at 2 microcoulombs. We should know from the past couple days that if I double the charge on one of them, what should happen to the force? It should double. So in a calculator, right, if I took 119.834, 119.834, and I multiply that by 2, my calculator tells me it's 239.668. So if I double this charge, let's say, to 4, oh snap, it did work. Okay. What if I double, let's bring this over to, I don't know, here. Double 39, if I just double this charge over here. So with 39.945, if I double that, I should get 79.89. So if I make this a 4, 79.89, yeah. Okay, cool. What if I quadrupled this? What's quadruple of 2? So 2 times 4, 8. So if I make this an 8 instead of a 2, this should be 4 times the size. So let's see what it is. 39.945. If I multiply that by 4, the number should come out to be just about 159.78. All right, so yeah, pretty much right. If we round that up, it would be 159.78. Okay. What if I double both charges? What should happen to the force? Not just double, right? Because if I just double this one, it doubles. What if I were to double both of them? Yeah, good. It would quadruple because 2 times 2. So let's see. That means, right, because this one we multiplied by a factor of 4, we got this number. So that means if I double both of these, it should also equal that 159. Let me move this to 4 and this guy to 4. Hell yeah. So this, again, agrees with what we've been doing the past couple days. Okay, so that shows us how the electrostatic force varies with the values of the charges. As we increase the magnitude, okay, we're going to increase the force. If you doubled the charge on one, all right, you would double the force. If you double both charges, you would quadruple the original force. Okay, bet. Well, how does the force vary with the distance? How does it vary with the distance? Okay, so right now let's put them, they're, all right, 2 centimeters apart, just about. What would happen if I move Q1 away? What should happen to the force? Should it get bigger or smaller, you think? It should get smaller, right? Just like gravity, right? The farther you get away from Earth's surface, the less gravity is going to affect you. Gravity is an attractive force. Now, electric charges can also be an attractive force if we have different charges, right? They're drawn towards each other. But how they both would differ is that electric forces can also be repulsive, like this. They're trying to get away from each other. And another way that, right, gravity, so they're both like inverse square laws. So like as we jump away right off the rip, it decreases dramatically. But now it's like not as big of a decrease every little bit you move back. But from here to here, we just dropped from here to here. We dropped quite a bit. We went from approximately 360 to 160. And we move 1 centimeter away. Now, if we move another centimeter away, we go from 160 to about 90. Not as big a jump. And if I move another centimeter away, I go from 90 to about 57. So it's getting less and less and less, okay, as you go farther and farther apart. So dramatically increases the force as we get closer to it, as we get farther away, all right, our force value is going to decrease. And also, we're going to have to wind up doing a couple calculations, just like I had shown you guys, all right, with the free calculator here. Okay. So I'm going to post your assignment for you guys, and then it's like, so it's an online lab. It's going to use this piece of information here that we were dealing with, and yeah, all right, you guys, that should make you good to go.